So this video we're going to be looking at how to solve more basic percent problems. The last video on percents was just kind of the basics and the mechanics of them, and this is going to be more focused on the problem solving aspect. So to solve percent problems, we usually break it down into three pieces. So every percent problem has three pieces to it that we're going to be looking at. We have the part, which is usually the smaller piece that we're taking out or that we're looking at. So if we're trying to, gauge the percent of fish with blue scales, well, the amount of fish with blue scales would be our part, because that's the piece that we're looking at or analyzing, or we're kind of separating off from the rest. The whole is the total amount of stuff that we have all together. So if we're looking at the amount of fish with blue scales in a river, the whole would be just every fish in the river. That's the whole amount of fish, and the part would be just those with blue scales. So the whole is everything we have. The part is kind of the special piece that we're looking at or that we're taking out in some cases. And then the percentage is just the percent of value that we have. So if 30% of the fish are blue, then 30% is the percent. It's usually the one with the percent sign with it. And again, this is usually going to be used as a decimal when we do our stuff. So if you have 30%, don't think of it as 30, think of it as 0.3. So this is a very typical percent problem. In a zoo, there are 150 animals. 30% of the animals are reptiles. How many reptiles are in the zoo? Well, let's focus on the first one, 150 animals total. That's all the animals. So that's going to be our whole, it's 150. 30% of them are reptiles. Well, 30%, so our percent is going to be 30%, or we should probably think of it as, like I said, 0.3, because that's how we're going to be using the value. And then the part is how many physical reptiles are there, not the percent, but how many physical reptiles would I count? Well, we don't know that, so that's going to be our question mark. That's the way to figure out. So in every percent problem, you're going to be given two of the three, and you have to find out the third. Not always going to be missing the part. Sometimes we'll be missing the percent or the whole, but it generally falls into this pattern here. So how do we figure out the missing piece? Well, there's a few methods depending on the problem you're given, but one method I found that a lot of people do because it's kind of a universal method is something called the triangle method. So in the triangle method, you're basically going to be using a triangle to help you figure out what you're going to do, because all the percent problems that we're going to be looking at can be solved by either multiplying or dividing the values that you have. Most, if like 90% of them, can be solved by simply multiplying or dividing one of the numbers to the other. But you have to know, when do you multiply, when do you divide? That's where the triangle comes in. So the triangle is set up like this. You have draw a triangle and you cut it into three pieces, one on top, two on bottom. The top piece is where the part number goes. So this is the part spot. The bottom piece, it doesn't matter the order of the bottom pieces, as long as you have the part on top, this is the important piece. The whole can go right here, and then the percentage can go right here. Remember, this is the percent as a decimal. So this is not 30, this is 0.3 when you put it in this triangle. Again, as long as you get the part on top, you're okay. It doesn't really matter how you arrange the bottom ones, but the part piece has to be on top. So the way you use this is you fill in the pieces that you know with the values that you're given. So you put your part number here, your whole number here, and your percent number here. Now remember, you're going to be given two of the three, so you're going to be able to fill in two spots. You cross out the spot that you don't know. So let's say you fill in your percent and your whole, you'd cross out the part spot. Now, once you've crossed it out, if the remaining numbers you have are side by side, you multiply them together, and there's your answer. If they're top and bottom, then you divide, and then there's your answer. And you always divide, it's always top divided by bottom, not the other way around. So top value divided by bottom value. So how does this look in practice? Because it's more easier to show it than say it. More easier. It's easier to show it than say it. So let's go back to this problem here. We have 30%, so 0.3. We have 150 animals total, and we don't know the part. So we're going to draw a triangle. Now the part goes on top, and we don't know that, so I'm going to put a question mark here. Don't know the part. The percent is 0.3, again, it's in decimal form, so I'm going to put that there. And the whole is 150, so I'm going to put that there in the whole spot. So I've filled in the values I know. I don't know this one, so I'm going to cross out the one I don't know. So I'm going to cross out or block out that box there. Well, what are my remaining numbers doing? Well, they're side by side. So what does that mean to do? Well, it means to multiply. So I'm going to take 0.3 times 150 to get my answer. And again, the key part of this is that your percent number has to be in decimal form. You do not do this as 30 times 150 because you're going to get the very wrong answer. So 0.3 times 50 gives me 45. So there are 45 reptiles total in the entire zoo, 150 animals total altogether, and then the percent of reptiles is 30%. So that's what I mean by fill in the spots you know and leave blank, or just put a question mark in the one you don't know and then just cross it out and work with the ones you have left. So what about this one? There are 12 people with red hair on a bus. 30% of the people have red hair. How many people in total are there? So 12 people with red hair. That's going to be my part because that's not everybody. It's just those with red hair. It's the piece that I'm looking at or that I'm taking out or that's special. This is the piece that is standing out. People with red hair. 30%, once again, that's my percentage. I'll put per there for percentage. How many people in total? So I don't know my whole. I don't know the total amount. So let's make our triangle. There are 12 as the part, 12 people total, or sorry, 12 people with red hair. My percent is 0.3. Again, you want to make sure you write this in decimal form. If you forget, the way you write it in decimal form is you write your percent, take your decimal, and you jump it up 2 spots. So that gives me 0.3, and that's the decimal form that I use. Do I know my whole amount? Well, not really, because it's saying how many people in total, which means I don't know it, so it's going to be a question mark here. So I'm going to cross out the box I don't know. My remaining numbers are 12 and 0.3, so I'm going to put 12 on top, 0.3 on bottom. That's a division problem, so this is really 12 divided by 0.3. So both these represent the same thing. If you want to write it as a fraction, this is here. If you want to write it as a more basic division problem, this is it. So if we take 12 and we divide it by 0.3, we should end up with a bigger number, which we do. So we take 12 divided by 0.3 and we get, whoops, my bad. Trace it here, there we go. So 12 divided by 0.3 gives me 40. Technical issues there. Now this is good because this is the whole. And most of the time, unless your percent's over 100, the whole should be bigger than the part, which makes sense. There should be more people on the bus than there are people with red hair on the bus because more people on the bus is counting everybody. So there should be more people total than just those with red hair. If I got like a 5, that wouldn't make sense. I can't have 12 people with red hair on the bus, but there only be 5 people total on the bus. That doesn't work out. So your whole, in most cases, will always be bigger than your part, which is why when you divide by a decimal, you actually make the number bigger as long as the decimal is under 1. So what about this last one here? 120 people surveyed, 30 were women. What percent were surveyed were women? Well, 120 people surveyed, that's everybody, men and women. So this is my whole, 120 people total. 30 were women. This is the special piece. This is my part. 30 were women. Not everybody, but 30 people, 30 physical people were women. What percent were women? So I don't know my percentage. So if we make our triangle, 30 people were women, so that's 30 is my part. 120 people total. I don't know what the percent is. So cross out the one I don't know. So now I have 30 divided by 120. Now again, be careful in how you write this out. It should be 30 divided by 120. It's top divided by bottom. So this should get you a pretty small number. So if I take 30 and divide it by 120, I get 0.25. Now, this is my percent answer. There are 0.25 of the people surveyed were women in terms of percentage. But I usually want to write my answer in percent form. I don't want to leave my percent as a decimal if it's my final answer. So how do you go from 0.25 to the percent form? Well, you take 0.25, you do the reverse. You jump it back twice. Once, two, jump the decimal point back twice, and you get 25% were women. So your final answer should be in percent form if you're finding the percent, but when you actually go to work it out, it's going to come out as a decimal, or you're going to use it as a decimal when you're actually working with it. The only time you leave it as a percent is when you have it as a final answer. So these are the three basic types of percent problems. And again, it all boils down to doing one of two things. You're going to take the numbers and multiply them, or you're going to take the numbers and divide them. So in this case, we multiply the numbers, got my answer. Here we divided the numbers, got my answer. And then here we divided the numbers and got my answer. So when you start doing this enough, you won't need it as much because you'll start to see when you divide and when you multiply. Some of you might already be able to see that if you have the whole and the part, you're going to divide. If you have the part and the percent, you're going to divide. If you have the percent and the whole, you're going to multiply. So once you get using this method, you'll probably start to wean off it because you'll just know, okay, I know that when I have these two values, I'm going to multiply because that's how I've done it for so long. I don't need to make the triangle because I just know it off the top of my head. But this is a good kind of introductory method to get into it and kind of get used to seeing how the problems are worked out. That way you can kind of improve on it later. That's it for this video. Hope you enjoyed the video. Have a good day.